Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I will be your host for today's video. And for today's video, we will be focusing on non-ideal gases and we will be exploring the Van der Waals equation. So the problem tells us to calculate the pressure exerted by 100 grams of butane at 100 degrees Celsius in a 100-liter vessel using the Van der Waals equation. The critical pressure and temperature of butane are 3.796 megapascals and 425.12 Kelvin, respectively. So we know that the Van der Waals equation is for gases that are not ideal, meaning they do not follow the usual PV is equals to nRT equation. But however, the structure of the formula is very similar. So yung Van der Waals equation natin is given by P plus A n squared over V squared, and then this is multiplied by V minus NB is equals to nRT. If you see, it's actually very similar to ideal gas equation kasi you have your pressure here and then yung volume here. They are multiplied to each other kasi nga they are separated by parentheses. And then meron tayong nRT on the right-hand side of the equation. But then in here, we introduced A and B. So what are A and B? So A and B are actually Van der Waals constants. So yung A natin is specific for every gas. And this is given by 27 R squared and then PC squared over 64 PC. So ano ba yung TC and PC natin? They are critical, this one is critical temperature, and this one is critical pressure. And in here, it is given in the problem. This is yung PC natin. And then this is your TC. This one is your critical temperature. Okay? And then yung B naman natin on the other hand is given by RTC over 8TC. Okay? So first, let's find those constants in the problem for butane. So A is given by 27. Tapos yung R natin, gamitin natin yung SI, which is 8.314 Pascal meter cube per mole Kelvin, and then squared yan kasi yung dito sa equation it's squared. Tapos yung TC natin, yung critical temperature is 425.12 Kelvin. And then you square that also. And then you square over 64. Tapos yung PC natin is 3.796 megapascal. But then in here, naka-Pascal lang siya. So we have to convert this into Pascal as well para ma-cancel. So for 1 megapascal, there is 10 raised to 6 pascals. Okay? And let's see kung ano yung matitirang units. So maka-cancel yung Kelvin here kasi pareho silang squared. So totally maka-cancel yan dito. MPa, of course, maka-cancel yan. Dito, Pascal squared. But then dito isa lang yung Pascal. So maka-cancel to, matitira yung isa. And then wala na maka-cancel. So, ang unit natin here is Pascal. And then, yung meter cube, naka-square pa siya. So, that is meter raised to 6 divided by mole squared. So, that is our unit for A. So, yung answer natin for A is equal to 1 point. Let's round it off to 5 decimal places. So, it's equals to 1.3836 Pascal, tapos meter raised to 6 per mole squared. Okay? And you can see na actually, since this whole thing is multiplied, is added to pressure, dapat yung unit dito is corresponding dun sa unit ng pressure. And if you can see dito, yung A natin is multiplied to mole squared. So, sa unit na to, maka-cancel yung mole squared. And then, it is divided by the volume squared. So, ito, meter cube squared yan. And maka-cancel din yan. So, yung matitirang mong unit here on the one-hand side is Pascal, which is corresponding dun sa naka-add sa kanya, which is pressure. And that's how you check if corresponding or homogeneous yung equation natin. Okay? Kasi dapat pareho sila ng units. Otherwise, you can't really add them together. Okay, so now let's look for B. So B is equals to R PC over 8 PC. So yung R natin again is 8.314 Pascal meter cube per mole per Kelvin. And then yung PC natin is 425.12 Kelvin over 8. And then yung PC natin is 3.796 megapascal. And again, we convert that into Pascal. So for every 1 megapascal, there's 10 raised to 6 Pascal. Let's see kung ano yung makakancel here. So makakancel yung megapascal. And then yung Pascal dito, makakancel. Kelvin also, and matitira is meter cube per mole. So, ang unit natin is meter cube per mole, and our answer for B is let's round it off to 5 decimal places again. So it's 1.16387 times 10 raised to negative 4 meter cube per mole. And if you can see, itong B natin is multiplied sa number of moles, right? And then in here, kapag multiply mo siya dito, multiply mo siya sa N, matitira yung meter cube. And again, naka-minus siya sa volume. Again, hindi mo pwedeng pag-minusin or ipag-add yung dalawang variables na hindi corresponding ang units. And in here, matitira yung unit ng volume, therefore, pwede mo na talaga siyang i-minus sa volume. So, tama yan. And now, let's just find N. So, that is the number of moles. In here, we're given butane. Ano ba yung butane? Butane is an alkane. And when you say it is an alkane, yung carbon atoms mo are connected by single bonds. And for butane, there are 4 carbons there. So we have carbon, single bond, carbon, single bond, carbon, and then another single bond. And then there's another carbon. And then, dapat, sa lahat ng carbon mo, merong 4 bonds dyan. So, how are you gonna make the other 4 bonds? You have to attach hydrogen to them. Kasi butane, again, is a hydrocarbon. So, let's attach this. Ano yung kulang dito? Meron na siyang isa. So, i-attach mo ng 3. So, isa, dalawa, 3. And then dito, meron na siyang dalawa. So, dalawa na lang. And the same for here. And dito din. Actually, dito 3. So, ilan yung carbon natin? 4. Tapos ilan yung hydrogen? 1, 2, 3, 4, 8, 9, 10. So, there are 10 hydrogen. So, ang molecular weight nito ng butane is 4 times 12 plus 10 times 1. And that is 48 plus 10, 58 grams per mole for butane. And how are we going to find the number of moles? We know that from this triangle, meron tayong mass. And the mass divided by the number of moles will give us the molecular weight. And if this is the molecular weight, kung i-divide natin yung mass by here, we will get the number of moles. So yung N natin for butane is 100 grams divided by 58 grams per mole of butane. So makikita natin na makakancel yung grams. And itong per mole sa denominator, mapupunta siya sa numerator. And the number of moles of butane present here is 1.72414 moles. So now if you want to isolate the pressure, we just have to make it the subject of the equation. So P plus AN squared over V squared times V minus NB is equals to nRT. Ito, multiplier yan. So we have to transpose it to the other side. Magiging divide. So therefore, P plus AN squared over V squared will be equals to nRT over V minus NB. And then, transposing this to the other side, yung plus magiging minus. So pressure is therefore equals to nRT over V minus NB minus AN squared over V squared. And that is your Van der Waals if you want to find the pressure. Therefore, yung pressure natin here is, yung N natin is 1.72414 moles. And then yung R natin, let's use yung SI, which is 8.314 314 Pascal meter cube per mole per Kelvin. And then yung temperature natin, it's 100. It is not the critical temperature, but the temperature of the vessel. So yung 100 natin, degrees Celsius, we convert to Kelvin. So it is 373.15 Kelvin. That is over yung volume natin ng vessel, which is 100 liters. But we have to convert it into meter cube kasi yun yung unit nung universal gas constant. So 100 liters, for every 1 meter cube, there is 1,000 liters. And then minus yung N ulit, which is 1.72414 moles. And then yung B natin, which is 1.16387 times 10 raised to negative 4. 16387 times 10 raised to negative 4 meter cube per mole. And then, minus natin yung this one. Yung A natin is 1.38836 Pascal meter raised to 6 per mole. And then, yung volume, number of moles, that is 1.72414. And then, moles. And then, yan ay naka-squared. That's over this one. Let's ayusin natin siya. Minus. And then, yan. Over V squared. And yung volume natin is 100 liters again. But you have to convert it into meter cube. So, for every... And this one is squared. So, this one, we have to convert. Okay? And let's see. Dapat matirang unit ay in Pascal. So, in here, makakancel yung liter. Yung meter cube, makakancel din here. Yung Kelvin, makakancel. Number of moles, makakancel. And then here, makakancel to. And yeah, nakakancel sila kasi pareho silang meter cube by this. So, matitira ay Pascal. How about in here? Yung mole, this one, nakaano siya ha, sa numerator, hindi siya nasa ilalim, hindi lang kasi kasya. Pero makakancel yan pareho. Okay? Oh, I forgot. Dapat square din to. Okay? So, yan. Ito square din, so makakancel yan. And then, yung liter here, and then yung meter. Meter cube squared is meter raised to 6. Makakancel yan. And, yes, indeed, ang matitira is Pascal. So, ang unit natin is in Pascal. Okay? So, ayan. Yung pressure natin is then equal to 53,184.02578 pascals. And that is your answer for the problem. So, I hope you guys learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.